Hello everyone, so today I'll be doing an overview of ZetaForge. ZetaForge is an AI platform for rapid development of AI and AGI solutions. The reason why we built ZetaForge is that when working with clients, it was really difficult to reuse the components we have built and also exchange them within the team. And we were trying also to keep up with all the new repos and new technique and new models that were coming out almost every day, and they are still coming out really fast. So when we say harness the power of AI, the goal is really to be able to integrate quickly within your solutions the state of the art and the cutting edge models and techniques and algorithms for your AI powered solutions. So to install ZetaForge, basically you need to do pip install ZetaForge and also ZetaForge launch. And just to make a few comments about what it is, it's really meant to be able to drag and drop blocks of code. And the code is really full code, so we have access to everything within the code and to access it easily and be able to modify it. And also have very powerful visualization that you can also drag and drop. So we didn't want to have any restriction of what you can do, and you can think of each block as a container because each block also has a requirements.txt and also it has a Docker file which allows you to make these blocks really portable and easy to exchange. So if a pipeline runs on one of your developer's machine, then it should work on every machine. So this was meant also to be able to easily deploy because now this structure could be deployed directly on Kubernetes. Yeah, so that's so let's just jump into it. So after you do this, you will be launching ZetaForge. So on the left, you have all the core blocks, and we have a few core pipelines, and you can also create your own if you need. So what we'll do now is basically build a very simple one called Canny Edge. And so now I just dropped the block here and I can go into it, and I have a few files in there. Cover image, which is basically the cover image that you're seeing here. Specs.json is what is used as the interface to the block. So this is generated automatically by reading the computations file. We also have a Docker file, and this one's pretty standard, so most Python blocks will just need this. You can change the versions if you need, or use a totally different Docker file. As long as it runs in the computer, the block will be able to run successfully and interact with the rest of the pipeline. So here in the requirements, we really recommend that you also put the versions because this will make this block more reusable in the future. So if there's some upgrades and changes to the function that you're using, fixing the version is very important. So now the computation, this is where everything happens. So you just need to wrap whatever code you need within a compute function. So here you define your inputs. So if you change these inputs and recompile, then it will add it to the block. And you also have the return statement. The return is basically a dictionary with the keys as the name of the variables. And that's pretty much all it is. So you can put all your code. You can add extra functions here and call these functions within the compute block. You can also add a folder, add files to this block, which is basically a folder with all the necessary information. And if you decide to add a folder, for example, it can be a GitHub repo, then you would call the functions from the GitHub repo within the compute function, which is the wrapper, which is what allows you to have the interface that will be able to connect with the rest of the pipeline. So yeah, so that's one thing. So maybe now that we're here, we can, if we decide to to edit the code, then we could basically click edit, and then we can change the code, and we can save it. And yeah, so then that keeps the history, so you're able to go back. If you did edits in the past that you didn't love, then you can go back and you can reactivate this code. By reactivating this code, you will basically be compiling this, and it will update everything within the block. So I mean, if we want to do a small let's see, we'll call this one like iterations. We'll save it, and you see the name is step here, and then we'll just save it, and now it become iterations. So these are the things that you can do. For us, what we'll do is we'll basically pass an image to Canny Edge. We'll also need parameters. Parameters here, it could be a dictionary. If it's a string, make sure that you put double quotes around them, or you can use the text box. Right, so here for parameters, it will take a minimum range. We'll start at 0. We'll drop in another parameter. Let's say, drop this one here, and then we'll drop this one here, the number of iterations. So the maximum will say 800. The steps will be, or the iterations will be 30. We just need to connect them to Canny Edge. So all these will be passed to the block when we run. We need to select an image. So I have an image just here. If we want to visualize the image, I mean, after the pipeline is launched, then we can add an image viewer. So this is view images. This is a view block. So you can see these are the some of the inputs that you can put to the blocks. They don't have like any input, so basically they're entry blocks. And then you have all the compute blocks, and these are the visualization blocks called view blocks. And we'll connect it, and it takes an image path, and it will display that image there, and it can take a list of image paths also. All right, so we'll add this here like this, and now we just need to run it. So now the pipeline is running. You could stop it if you want, and we can also go see in the logs if everything's happening correctly. And we see that there's an issue. So we can see the error here, and we know why, because we did change the variable. So let's go back and let's go see to computation. So the last code, we basically added like a new input, and this input is not even here. So this means that step won't be updated. So what we can do is go back to the original code, and just let's check, because the name has changed, the connection has been lost. So now let's run it again. Now we can go look at the blocks. So this will basically build all the containers if they're not already in the Docker cache, and it will produce the results based on running the code. So we have a success. And this means that this was the image that we entered, and this is the output images. And if you want to visualize it in the browser, you just click here, and then you have access to what it produced. So this is a very simple pipeline, and it's kind of nice. We also had an error, so we corrected it, and so yeah, so that's a first step.